Hi everyone, so in this video we are going to be talking about permutations. So a permutation is an ordered arrangement of a given set of objects. Now this word right here, ordered, is very important. For permutations, order matters. And we'll come back to that idea later, but for now, just keep it in the back of your mind. The number of permutations of indistinct items is n factorial. So that is n factorial, like that. Where n factorial just means n times n minus 1 times n minus 2 all the way down until you get to 3 times 2 times 1. So you just take the number, multiply it by 1 less, multiply it by 1 less, all the way until you get to 1. Okay, so to start out, we are just going to be looking at some factorials and getting those. So first off, 6 factorial. Easy enough. It is 6 times 5 times 4 times 3 times 2 times 1. You just start at 6, go down by 1 every time until you get to 1. Multiply all of those together now, and you get 720. Alright, next one. Let's try 6 factorial over 4 factorial. So 6 factorial is 6 times 5 times 4 times 3 times 2 times 1. 4 factorial is 4 times 3 times 2 times 1. So I'm just expanding both of them out. Now keep in mind we could multiply the entire top and the entire bottom together, and we get 720 over 24, and we could divide that. However, we're not going to do that because there is an easier way. If we notice, this is a fraction. There's a 4 on top and bottom that can cancel, a 3 on top and bottom, 2 on top and bottom, a 1 on top and bottom. All of that stuff just cancels out. So all that's actually left is 6 times 5, and hopefully we don't even need a calculator at that point. That's just 30. So it becomes much easier if we just cancel out everything first. Now for part C, this is one that we definitely don't want to use a calculator for. And in fact, we can't. So on top, we have 100 factorial. So we are going to start writing that out. However, we are not going to write it out the entire way. So here's what I mean. It would be 100 times 99 times 98 times 97. And I assume everyone gets the pattern, so we're just going to say ... times 2 times 1. All of the stuff in this ... that is 96 times 95 times 94. It's all the numbers that we didn't write are right there. Right? Luckily, we're not going to have to worry about that ... for long. So on the bottom, we have 98 factorial, which is 98 times 97 times ... times 2 times 1. The cool thing is, just like before, we can just cancel stuff out, because this time if you actually tried to put this in your calculator, if you actually punched in 100 times 99 times 98 times 97 and kept going all the way to 1, well, first off, you're going to be typing for a while because that's a lot of numbers. But secondly, your calculator is not going to be able to do it. That is a ridiculously big number that your calculator actually can't handle. At some point along the way, it's just going to tell you error. Luckily, we're going to be able to do something that the calculator can't, because we can see that the 98 cancels, the 97 cancels, the 96, 95, 94, everything in that ... cancels. Until the 2 and the 1, all of that stuff is the exact same. So all we really have is 100 times 99, which is 9,900. So congratulations, you can do something that your calculator can't. So let's go ahead and try the next one. So just like order of operations, we are just going to do the parentheses first, and then this becomes a very easy problem. So 6 minus 4 is 2. 2 factorial is just 2 times 1, which is just 2. For part E, we're going to do something similar. We're just going to do the parentheses first, and then we'll divide it like we did B and C. So we're going to have 8 factorial over 8 minus 5 is 3. So on top, that's 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. On the bottom, it's just 3 times 2 times 1. But we still get to cancel some stuff. And so if we just multiply out the 8 times 7 times 6 times 5 times 4, we should get 6,720. All right, so that's the basic for factorials. So for number 2, in how many ways can 8 books be arranged in a bookcase? So we have 8 spots for 8 books. That is just going to be 8 factorial. So that's 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1. Multiply all of those together, and we get 40,320. All right, now the reason that was just 8 factorial is because it was 8 books and we're arranging all of them. But what if we had 8 books, but only, say, 4 of them would actually fit on the shelf? So now, not only do we have to arrange the 4 books on the shelf, but we also have to pick which ones we're going to put on the shelf in the first place. That is where the full permutation formula comes in. So the number of permutations of n things taken r at a time is n factorial over n minus r factorial. Right, now keep in mind, just a way to keep this clear in your mind, n is always the number of things you are choosing from, and r is the actual number of things you are choosing out of n. Meaning, in our bookshelf example, we had 8 books, and if we chose, say, 4 of them, n would be 8, because that's how many total things we have. R would be 4, because we're picking 4 of them. Now, an easy way to remember that is n is always going to be greater than or equal to r. So if you have those two numbers, 8 and 4, just know that the bigger one is always going to be n. Okay, so let's get some practice using this formula. Before we do, one last little tip, because this is about to come up. 0 factorial is 1. I know that's a little counterintuitive, but 0 factorial does equal 1. So if you ever see that come up, it's 1. All right, so let's go ahead and try A. 7p2. So remember, 7 is in, 2 is r. So we're just going to plug these into the formula. It would be 7 factorial over 7 minus 2 factorial. And we can do this the same exact way as we were doing before. So 7 factorial is 7 times 6. Try not to skip numbers like I do. Times 5, times 4, times 3, times 2, times 1. All over 7 minus 2 is 5, so that'd be 5 factorial. And we can cancel a whole bunch of stuff out. And in the end, all we have is 7 times 6, which is 42. All right, let's try the next one. So n is 12, r is 3, so it'd be 12 factorial over 12 minus 3 factorial. So we're going to have 12 factorial, which let me go ahead and just simplify that actually to 9 factorial on the bottom, just to make it a little more clear. So 12 factorial is 12 times 11 times 10 times 9 times blah 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 all the way down to 1. 9 factorial is 9 times 8 times blah, 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 down to 1. So all of that part is what cancels. So in the end, all we actually have is 12 times 11 times 10, which is 1,320. All right, let's try the next one. In this case, 7p7, n and r are both 7, so it's going to be 7 factorial over 7 minus 7 factorial, which is 7 factorial over 0 factorial. Remember, I said 0 factorial is just 1, so this is 7 factorial over 1, but anything over 1 is just itself, right? So this is just 7 factorial. That's it. And it's going to be 7 times 6 times 5 times 4 times 3 times 2 times 1. All right. So multiply all of these out, and you should get 5,040. All right, last one. Go ahead and try D on your own. Pause the video, give yourself some time. The answer will pop up on the screen right now. So for part D, the answer is just 1, because it ends up as 7 factorial over 7 factorial. Anything divided by itself is just 1. All right, so let's go ahead and start trying to use this. So in an office of 10 people, 2 are chosen as Employee of the Month and Team Player of the Month. In how many ways can this be done? Okay, so first off, the first thing I want to point out is that 2 things are being chosen, Employee of the Month and Team Player of the Month. Those are 2 different things. So order matters. If you got Employee of the Month, that's different than you getting Team Player of the Month. So order matters here. All we're going to have to do is we take the number of people that we're choosing from, that's 10, P, and then the number of people we're actually choosing, that's 2 in this case. All right, now here's where I'm going to let you off the hook a little bit. You do need to know how to do it with factorials. However, for especially like word problems like this, there is a nice, fast, easy way to do permutations. So if you have a TI-83 calculator, then if you go to the Math button, scroll right to PRB, that's for probability, and you'll see usually the second option is NPR. That button allows you to type in 10, then that NPR button, and then 2, and it automatically gives you the answer. However, if you do not have a TI-83 or TI-84, then you can use a website called Desmos. So it's desmos.com/calculator. That is desmos.com/calculator. I'm going to go ahead and take you over to that website. That way you can see how this works on there. Alright, so here we are on Desmos. So there's 2 ways we can go about this. The first is if you show keypad and then go to Functions, scroll all the way down, you'll get to a category called Number Theory. In there, you will see NPR. Click that. And then if you want to do 10P2, all you have to do is put in 10, 2, and it gives you the answer of 90. Now, if you don't want to go to that Functions button every time and have to scroll through and find it, you can also just straight from over here put NPR, open a parentheses, and then put your 10, 2. It'll still do the exact same thing. So this is more just if you forget that it's NPR, you can go looking for it down here. But if you know that already, just type in NPR, capital P, NPR, put in a parentheses, 10, 2 in this case. So that's 90, so let's go back to our problem. So whether you did it with a TI-83 or 84, or you did it with Desmos, you get an answer of 90. So there's 90 different ways to choose 2 people out of 10, specifically when order matters. All right, number 5. Suppose you watch 20 movies over the summer. In how many ways could your top 3 favorites be chosen and ranked? All right, now keep in mind, these are being ranked, which means Star Wars being your number 1 favorite movie is different from Star Wars being your number 2 favorite movie. So order matters again. So out of 20 movies, we are going to pick 3 of those. So 20p3. Again, go to your calculator or go to Desmos, put in 20p3, and you should get 6,840. All right, a president and vice president are to be chosen from 7 students. In how many ways can this be done? So again, you becoming the president or you becoming the vice president, those are different things. So order matters. Which again means it's going to be a permutation. So out of 7 students, we are going to pick 2. Because 1 for president, 1 for vice president. Put this into your calculator of choice, and we get 42. All right, number 7. So from a team of 12 players, 3 players are to be chosen as MVP, most improved, and team player. If no player is to be rewarded with more than one of these awards, in how many ways can this be done? Once again, it is different if you get MVP versus most improved. So order matters. All right, so if order matters, it's a permutation again. Out of 12 players, we are going to pick 3. So put 12p3 into your calculator, and we get 1,320. All right, last one for permutations. Out of 120 swimmers in a swim meet, the top 12 swimmers will be awarded ribbons, 1st through 12th place. In how many ways can this be done? So again, obviously it matters if you get 1st place versus 12th place, right? Those are 2 completely different spots. So order matters. So out of 120 swimmers, we are going to pick 12. Once again, put this in your calculator, and we get approximately 5.0500465977. Then, depending on what calculator you're using, you're either going to see E24 or times 10 to the 24th. On a TI 83 or 84, you're going to see that one. On something like Desmos, it's going to say times 10 to the 24th. So what does this answer mean? This means that this is a huge number. So it literally means you're going to take the decimal place and move it over 24 times to the right, and that's your actual number. So it's insanely big. We're not going to write all of those zeros. So this is a case where we would approximate it. We're not looking for the exact number. It's a lot of ways. All right, so with that said, that is it for permutations. In the next video, we're going to talk about something very related called combinations. And specifically, the one difference is that for permutations, order matters, which is why I keep writing that off to the side. For combinations, order is not going to matter. So we'll take a look at those in the next video. I will see you there. Thank you.